Dear student, previous class we discussed about the basics of vector differentiation. That is how to apply dot product, cross product of two vectors, how to verify the two vectors are perpendicular to each other, parallel to each other, and then we learned two important definitions, that is operators. One is a vector differential operator and a Laplacian operator. And we discussed about using vector differential operator, three more important definitions, that is a gradient of a scalar, divergence of a vector, curl of a vector. And in the gradient of a scalar, we learned about how to find a unit normal vector to the given surface, how to find the angle between the two surfaces, and then directional derivative of a given surface. Now we'll discuss the problems on that. Okay, that is first one. Find what is this represents gradient. Grad phi means find the gradient of a scalar when phi is equal to 3x square into y minus y cube into z square at a point 1, minus 1, minus 2 and minus 1. So we need to find the gradient of a given scalar at this point. Sometimes the points may be given, sometimes we won't give any point. Just we need to find the gradient of a scalar. That is, procedure is, first consider the given scalar. Phi is equal to given scalar. We need to find the grad phi. So consider that grad phi. Grad phi is equal to del phi. What is del phi? We need to find the partial derivative of a phi with respect to x plus partial derivative of a phi with respect to y plus partial derivative of a phi with respect to z multiplied by ijk. We know the partial derivative. What is phi? First substitute phi here in this definition. So differentiate phi with respect to x first, and then differentiate phi with respect to y, and then differentiate the same phi with respect to z. Now here, when you differentiate with respect to x, the variable y and z acts as a constant. So the derivative of this with respect to x is 6xy. The derivative of x square is 6x into y, and here there is no a, so this is 0. So 6xy minus 0 into I, that is 6xy. Similarly, differentiate here with respect to y. So here we have a derivative of x square as a constant, y with respect to y is 1, so 3x square, and y cube differentiation is 3y square into z square into j. And now differentiate this with respect to z by treating x and y as constant, so this is 0, and z square differentiation is 2z into y cube into minus. So this is the gradient of a given scalar. But here we need to find this gradient by using the point 1, minus 2, minus 1. So this represents, this is x value, this is y value, and this is z value. So in the gradient, substitute, replace x by 1, y by minus 2, and z by minus 1. You will get gradient of a given scalar at a point 1, minus 1, 1, minus 2, and minus 1. So this is the working procedure of finding gradient of a scalar. Next, we'll discuss about one more problem on the next topic, that is find the unit vector normal to the surfaces x cube plus y cube plus 3xyz is equal to 3, and some point is given. Okay, unit vector normal to the surface. To find out a unit vector normal to the surface, first I want to find the gradient of a scalar, the given scalar. So what is a scalar here? Phi is equal to x cube plus y cube plus 3xyz, shift this here, minus b. So this is a given scalar. First I want to find the gradient of this, similar to the previous problem. So consider the gradient of scalar. Means differentiate this with respect to x, y, z separately, partially. So I will replace phi by the given surfaces, and now the derivative of this with respect to x is 3x square No x here, no x here, so the derivative here is 3yz. So this is the derivative of phi with respect to x. Now the second term, derivative of this phi with respect to y. So this reduces to 0 because x is constant. This is 0. Y cube differentiation is 3y square. This derivative is 3xz. Now the derivative of a third term. X cube is 0 because I am differentiating with respect to z. Y cube is also 0 because I am differentiating with respect to z. So here the derivative of this is not 3z square. This is a 0. There are no term here. And this is also 0. There are no 3z square. 3xy. That's it. No z square. Okay. Now this is the gradient of a scalar, but I want to find at this point. So replace x by 1, y by 2 and z by minus 1. So if you replace x by 1, you will get 3i because how you get minus 3 here? 3 along with here minus 1 we have. So 3 into 2. So this is 3 and here 3y, y is 2, so 6 into minus 1, so minus 6, 3 minus 6 is minus 3i. Now here 3 into 2, that is 2 square, so for 12, and here xz, so minus 3, so 12 minus 3 gives 9. Now replace it. You don't have 3z square, just here 3xy, 3 into y, y is 2, x is 1, so 3 into 2 into 1, 6, so 6k. So this is the gradient of a scalar at a point 1, 2, minus 1. This is just a gradient, not a unit vector normal. What is a unit vector normal of a surface? The ratio of gradient of a scalar divided by its magnitude. So consider the gradient of a scalar first, and the magnitude is nothing but if you have a vector ai, bj plus ck, then if this is a vector a, then the magnitude of a vector a is nothing but square root of a square plus square root of b square plus square root of c square, that is I coefficient of I square plus coefficient of j square plus coefficient of k square. Similar to that, if you find the magnitude for this, you will get 3 root 14. So this is a unit vector normal to the surface. Observe, up to gradient, the procedure is similar to the previous one. For that, I am adding one step, that is finding the ratio of a gradient of a scalar divided by its magnitude. This gives unit vector normal to the surface, and we are denoting this one by n cap. So this completes the second problem, the procedure of unit vector normal to the surface. Now we are going to find the angle between the two surfaces. Okay, here is given the phi 1 and the phi 2, and we are finding the angle between these two surfaces at a point 2, minus 1, 2. So first consider the given surfaces. Phi 1 as x square plus y square plus z square, shift this here, minus 9. And consider the second surface, phi 2 as x square plus y square, shift this here, minus z and minus 3. How to find the angle between the two surfaces? To find out that, first I want the gradient of the two surfaces, del phi 1 and del phi 2. So find out those two. First find the del phi 1. That is, first consider the gradient of phi. In that, I will take the phi 1, replace phi by phi 1. So here I know what is phi 1. Differentiate phi 1 with respect to x. You will get 2x into I. These three terms reduce to 0 because these three terms independent from x. Then differentiate phi 1 this with respect to y, you will get 2y. Differentiate phi 1 with respect to z, you get 2z. This is del phi 1. But I want this at a given point, x is 2, y is minus 1 and z is 2. So replace x by 2, you will get 2 into 2, 4. Y by minus 1, so 2 into minus 1, minus 2. 2 into 2, 4. So this is del phi 1 at the point 2, minus 1, 2. Similar to that, now we are going to find the del phi 2 for a second surface. So differentiate phi 2 with respect to x first. X square is 2x. Differentiate phi 2 with respect to y, that is 2y. Differentiate this with respect to z, so 0, 0, minus z differentiation is minus 1 into k. Now here replace x by 2, y by minus 1, z by 2, but there is no z here, so this term will remain the same. 2 into 2, 4, 2 into minus 1 is minus 2, and no z, so minus 2. Now I have a del phi 1 and del phi 2. Now to find the angle between the two surfaces, the formula is cos theta is equal to the ratio of dot product of the two gradients, that is del phi 1 dot del phi 2 divided by its magnitude. So that is, apply the dot product here. We know the dot product already. Coefficients of phi, that is 4 into 4 is 16, plus minus 2 into minus 2 is a plus 4, plus 4 into minus 1 is minus 4. So plus 4 minus 4 gets cancelled, the remaining is 16 in the numerator. And find out the magnitude for these two and simplify, you will get 6 root 21. If you simplify this, okay, 2 8 and 2 3 so you will get 8 by 3 square root of 21. This gives the angle between the two surfaces, that is theta is equal to cos inverse of 8 by 3 root 21. So this is the angle between the two surfaces. This is the working procedure. Observe here once again we need the requirement of gradient of a scalar, and then apply the dot product for those two with the magnitude. Okay. If the resultant is 0, we call these two as orthogonal to each other. Now, the next concept is directional derivative. Here I am giving some scalar at a point 1 minus 1 1, and I am giving some vector in the direction. Okay, I want to find the directional derivative of a scalar. As usual, for directional derivative also, first I want to find the gradient of a scalar. So first find out the grad phi. So here I want to differentiate the phi with respect to x first. So numerator we have a x, denominator also we have a x. We need to apply the quotient rule. Okay, we know that numerator into derivative of denominator minus denominator into derivative of numerator divided by denominator square. So apply that, minus plus actually, and then phi with respect to y. Here I want to differentiate this with respect to y. No need of a quotient rule, or if you want you can apply the quotient rule, no problem. You will get this result. Similarly, differentiate phi with respect to z by using the quotient rule. Now this is the gradient of a given phi in general, but I want at this point, so replace x by 1, y by minus 1, z by 1. If you replace x by 1, y by minus 1, z by 1, I will get this. So this term completely vanishes. You check out that. Okay. Now, there is a gradient of a given scalar. Now consider the given direction, that is the vector d, I minus 2j plus k. What is the directional derivative? The formula is, we need to find out the d cap first. What is d cap? Vector d divided by its magnitude. So find out that I minus 2j plus k divided by its magnitude is 1 square plus minus 2 square is plus 4 plus 1 square. So this is square root of 6. So that is the magnitude. Now the directional derivative is nothing but del phi dot unit vector d. That is del phi dot unit vector. We have a del phi here, I by 2 plus j by 2 dot this vector. Apply the dot product here, you will get the resultant as minus 1 by 2 root 6. So this is the directional derivative of a scalar at a point 1 minus 1 1 in the given direction I minus 2j plus k. So this is your working procedure of finding the directional derivative. Observe all the 4 problems. The basic requirement is gradient of a scalar. These are the problems related to a gradient of a scalar. We may ask just find a gradient of a scalar at a given point, or find a unit normal vector of a scalar at a given point, or find the angle between the two surfaces, or find the directional derivative of a given surface. Now we'll discuss about the divergence and the curl of a vector. Find the divergence and the curl of a vector. F is given here. First I will consider the given force vector F. We know how to find the divergence of a vector, that is del dot f. Consider del dot f. That is, this is my del dot, this is my vector f. We know what is a dot product. The product of coefficients. I coefficient is here, this is. So, partial derivative of x, y, z plus y square z with respect to x plus the partial derivative of j coefficient with respect to y plus the partial derivative of k coefficient with respect to z. This gives divergence of a vector. So now observe here, the partial derivative of this with respect to x is yz and this term is 0. Now the partial derivative of this with respect to y is 3x square is 0 and here 2yz. Now the partial derivative of this is, here I have a z square differentiation is 2z, that is 2z into x minus z derivative with respect to z is 1 into y square. So yz plus 2yz is 3yz, 2xz minus y square. So this is divergence of a vector. This is my divergence of a vector. Now I want to find curl of a vector. What is the curl of a vector? Del cross f. How to define that? A determinant. First row is ijk, second row is a partial derivative coefficient, and the third row, first is a I coefficient in a given vector f, and then j coefficient, and then k coefficient. Expand this determinant. I into, we know how to expand this. Partial derivative of this with respect to y, so this is 0 minus 2yz. Partial derivative of z with respect to, partial derivative of this with respect to z, the first term is 0 and here y square. Similarly, expand the remaining term, you will get this. So this is called curl of a vector. You need to calculate this because you know the determinant very well. Okay. This is the procedure of finding divergence and the curl of a vector. Now we'll discuss one more problem on the same. Observe, in the previous problem, the vector f is given directly, but here I am not giving a vector f. You need to find out by using the gradient of a scalar. What is this? This is a scalar phi and del phi. This is gradient of a scalar. Okay. First consider the phi. Phi is nothing but x y cube z square. First find out that this vector f. What is vector f? Del phi means gradient of a scalar. We know already how to find that. Differentiate this phi with respect to x, y cube z square. Differentiate this phi with respect to y, 3xy square z square. Differentiate this with respect to z. Derivative of z square is 2z into xy cube. This is my gradient of a scalar or a vector f. Now using this vector f, I want to find the divergence of a vector f and curl of a vector f at a given point. First consider divergence of a vector f. Del, this is my del, dot, this is my vector f. Apply the dot product, that is partial derivative of y cube z square with respect to x, partial derivative of 3xy square z with respect to y, partial derivative of 2xy cube z with respect to z. If you apply the partial derivatives, observe there is no x here, so the derivative is 0. Here I am differentiating with respect to y, so y square differentiation is 2y into 3, so 6xyz square. And here I am differentiating with respect to z, so derivative of z with respect to z is 1, so 2xy. This is my divergence of a vector f, but I want to find this at this point, means x is 1, y is minus 1, z is 1. Replace that, you will get minus 8. Observe here, 6 into 1 into minus 1 into 1, so we will get minus 6. And here 2 into 1 into minus 1 whole cube is minus 1, so minus 2. So that gives minus 8. So this is divergence of a vector f at a given point. Now the curl. Curl means del cross f, that is determinant. So consider that ijk, partial derivatives and the I coefficient first, j coefficient and k coefficient. Expand this. You will get like this, 6xy square z and everything. and here replace x is 1, y is 1, z is 1. Here I'm directly consider the points. The resultant you're going to get 0. You can verify that. Okay. This gives divergence and curl of a vector F. So practice these problems first. So these are the problems you're going to get in the examination, and the next problems are, we may ask solenoidal. Solenoidal means del dot vector F is 0. Means here if the result instead of minus n, if it is 0, we call the vector F is solenoidal. And what is irrotational? Del cross vector F is 0. So observe here in this problem, unfortunately the del cross vector F is 0. So this is a irrotational, not a solenoidal. Irrotational. Okay. If time permits, we'll discuss the problems on solenoidal, irrotational, and the scalar potential also. So concentrate on these problems. Here I am explaining only one problem from each concept, but in the notes I will give the 2 to 3 problems in each concept. Okay. So continue the remaining problem in the next class. Thank you.